Okay, so I'm now going to open the notebook that we put for you on the page of the first lesson on the course website. Just download the Python Basics notebook that we have on the page. And here within Jupyter, just use the upload button and select this notebook. Press upload and then click it, and you will see the notebook opening for you. Okay, you can see the entire notebook, and then you can also execute it on yourself. It will be very useful, so you can also play with it and see that you understand everything. And later, when you want to use the code, maybe for solving one of the exercises, you can just copy paste part of the code that are relevant for you, and this way you have nice access to everything we do. Okay, so let's start with a very, very basic of Python programming and start speaking about variables and types. So this is how you define a variable in Python. That's the syntax. You have the variable name, you use the equal sign, and you put some expression or some value that you want to assign to it. And that's it. We define a variable named var, and you can see it's equal to 10, like we wanted it to be. And then we can use this variable and do all kind of manipulation on it. We can increase it by 1, and you can see you have the result correct. Pretty much like every programming language that you might know. Now it's important to note that variable names in Python are case sensitive. So you can see that here I define a variable named var, but this name is capitalized. It has the first letter in uppercase. And you can see that the var with the uppercase v is not the same as the var with the lowercase v. These are two different variables, and as far as Python is concerned, these two variables have nothing to do with one another, okay? So two completely separate variables just because Python is case sensitive. It actually matters what is the case of the variable names. Okay, so there are many valid names that you can give to variables. So it can be just one letter, or it can be some combination of letters and digits and even underscores that you can put up together to form some name, like some variable name 55. And you can also use uppercases, and in many programming languages you'll see this convention of what is called the camel case convention, of this way separating words within variable names. But that's not actually the convention within Python. So in Python, the convention is to use this kind of naming just to separate with underscores. And variable names and function names, we do not separate with uppercase. We only do it for classes and types, which we're going to learn much further in the course. Okay, and now that we have those variables defined, we can just, do all kinds of manipulation on them. Like you can see here, we can increase some variables, we can multiply them, do all kinds of manipulations. It's important to note that some things are not valid variable names. So for example, we saw that we can have letters and digits as part of variable names, but it must begin with a letter or with an underscore. You cannot begin a variable name with a digit. So if it were the second symbol within this variable, it would be fine. So you can see now it's okay, but you cannot begin it with the digits. Okay? And likewise, you're not supposed to have other kinds of symbols, like exclamation mark is not a valid variable name. Okay? So this is not valid either. Now Python also allows you to define multiple variables in the same line of code. Like you see here, we can do something like a, b, c equals 1, 2, 3. And it knows to assign 1 to a, 2 to b, and 3 to c, like you see here. And again, you can see we do all kinds of manipulations. We update the value of a, and it updates accordingly. Now later we're going to understand more deeply how this index works, but for now just take it for granted that it works, that as long as the left-hand side and the right-hand side match, namely they have the same number of expressions, then you can do multiple assignments within the same line of code. Now, like I said, it must match, okay? So if you take A, B, C and try to assign 4 values, you will get a value or too many values to unpack, okay? So according to the left-hand side, you expect 3, but you actually got 4, so it doesn't work. And likewise, if you have too few, it will say not enough values to unpack. So it's expected 3, it got 2, like you see here. Again, it doesn't work. It has to be exactly 3. Sorry. It has to be exactly 3 for it to work properly. Now, sometimes when you do this kind of assignment of multiple values, we're not really interested in everything on the right-hand side. Again, we're going to see some examples throughout this code, but sometimes what people do, if you say you only care about the middle 2 variables, you don't care about the first one and the last one, but we said that you must have the same number of items. You need to have 4 variables on the left-hand side in order for it to work. So what people sometimes do, it's again very common convention, is to use an underscore to indicate a variable that you don't actually care about its value. So just as a placeholder for something. And this way, using underscore, you can use the same variable name in the 2 sides. You just discard those values, and only 2 and 3, you actually keep them and assign them to x and y, respectively. And you can see that the values of x and y are indeed 2 and 3. And the value of underscore, by the way, you can see it's now 4, it's not 1. So what happens is Python actually interprets this line from left to right. So it assigns 1 to underscore, it then assigns 2 to x, 3 to y, and then it assigns 4 to underscore, thereby overriding the previous assignment of 1. So by the end of this line, 1 is already discarded, and now underscore is equal 4. But again, it's important to know that as far as Python is concerned, underscore is a variable just like any other variable, okay? So it's a legitimate variable name, and you can see it's a variable. You can use it like any variable, and it works. Okay, so we saw that we could assign 2 to x. Now, if you're not sure about the type of some variable that you defined, you can use the type function that if you apply it over some value, it will tell you what is the value of this type. And you can see that x that we define is an integer. It's a class int, like you see here, okay? So it's a number, and numbers that are whole numbers in Python are just integers. And that explains the type of x. Now we can see some different types in Python. So we can see again, 4 is a whole number, so it's an integer. But if we have something like 3.14, which is some decimal number with some digits after the decimal point, then you can see now it's not an integer, it's a float. It's a floating point number. And likewise, if we give it a string, we can see that the type of a string is a string. It's a class str. Okay. Now, an important theme of Python that we need to understand that within Python, everything is an object, and every object has a type. Now, type itself, as confusing as it may sound, is also an object, and it also has a type. So you can take everything in Python and assign it to a variable. So you can take the output of the type of something and assign it to a variable t. And now t is not x, it's the type of x, which, like we saw, the type of x is class int. Okay, so now if we print t, we can see that it's actually an int. We can print it like that. Okay, again, class int. And now we can take this class int, this type object, and you can even ask what's the type of that. And the type of a type, it turns out, is a type. Now you can try to go even further than that and ask what is the type of t, okay? And the answer is that the type of type is again a type, okay? So it doesn't go on forever. And actually the type of t is the same as the type of t, okay? So the type of any object is some type variable, and the type of that will always be a type. Another type of variable that is actually very common and people very often use and is very useful is the none type, okay? The none is some kind of a placeholder for a missing value that people often use. We're going to see many examples in which it comes to be handy. So you can see here we define a none variable, we assign it to a variable named a, we then print a, we can see it's a none value. And now we can ask what is the type of a none value. It turns out that it has its own specific type. So a none is just a none type. And then again, you can ask what is the type of a none, and the answer is, as usual, just a type. Okay, let's speak a little bit about Booleans. So Boolean variables are variables of just true and false. Again, very common throughout pretty much every programming language, and also applies to Python. So many expression and operators that you use in the Python language will actually result in a result which is a Boolean type. For example, if you have two integers or other types and you want to compare them using the equal operator that compares two things and checks whether they're equal or not, like here you can compare a to b, which is a is 5, where a is 5 and b is 3, then as you expect, the answer turns out to be false. So you get a false Boolean variable saying that a is not equal to b. But if you ask whether a is equals to b plus 2, here the two sides are 5, so the answer is true. Yes, it is equal. And you can also ask whether a is not b using the the exclamation mark equal operator, meaning not equal in Python, thereby checking whether a is not b, and the answer is yes, they are different. And then you can use all kind of comparison. You can check whether a is greater than b, yes, whether a is greater than a, no, whether it's greater or equals to itself, and the answer is yes, and likewise whether it's smaller or equals, and you get the expected outputs. Now, of course, these Boolean values, like everything else, they're objects with type, and you can assign them to variables. So you can take the expression a bigger than b, you can evaluate it, and then assign it to a variable named condition. And since a is indeed greater than b, condition will now be equal to true. And you can print it and see that the condition is true. And the type of condition is bool. It's a Boolean variable, and that is the class of Boolean values. And like before, you can do multiple assignments, and you can actually use the keywords in Python, true and false. In some programming languages, it's in lowercase. In Python, it's actually capitalized, so it will be true with capital T and false with capital F. And these are actually reserved names that you can assign if you want directly something to be equal to true or to false. Now, other nice operators that you can use is, in order to combine different Boolean expressions, is the and or and not operators. So and basically checks whether you have two expressions which are true. So, for example, true and false will be false. You need two of them to be true in order for it to be true. So if you ask whether 5 is greater than 3 and 2 is greater than 3, the answer is no, because 2 is not greater than 3, and you need it to also happen in order to get it true. Now, or works the other way around. For or, it's sufficient that one of the expressions will be true. So if you have true or false, the answer is true. So if you ask whether 5 is greater than 3 or 2 is greater than 3, the answer is yes, because the left-hand side, 5 greater than 3, is true. Or you can use the not expression, the not operator, to flip the Boolean value. So it will basically turn true into false and false into true. So 5 is greater than 3 is true, and now you ask whether not 5 is greater than 3, so it's essentially asking not true, which is false. Okay, and you can even use it directly. You can use the false directly and ask whether not false, and of course not false is true, like we said. Now when you do all of those kinds of comparisons, it's very important to know the types of what you work with. So like we saw before, you can have an integer 3 or you can have a string 3, and these are very, very much not the same thing. They are two completely different entities, and if you try to work with them together, very commonly you will get an error or you will get an unexpected result. So for example, if you ask whether the integer 3 is equal to a string where it says 3, the answer of course is false, because this one is a number and this one is a string. Of course they're not equal. If you ask whether it's not equal, the answer is yes, because these, again, two different types. Sometimes Python knows how to handle these type conversions. So for example, it can know, especially in Python 3, it knows pretty much well how to handle integers and floats together. So pretty much everything that you do with integers and floats, you should get a sensible result that is something you expect. So for example, Python knows to convert 3.0 to 3. If you compare an integer 3 to a float 3, okay, so like we saw before, the type of 3 is an integer, the type of 3.0 is a float. These are two different objects, but Python knows how to convert them, okay? So it knows that 3 and 3.0 is the same, and it gives you true even though there are different types. Now, of course, if you compare an integer to the non-type, then you will get a false. Okay, and again, if you try to do kind of a comparison, like asking whether something is greater than another, then it becomes even less well-defined. So, and it also varies between different versions of Python. So for example, this used to return false in Python 2. In Python 3, it just gives you an error if you try to compare an integer to a string using the greater operator. Now you can do all kind of useful conversion between types. And one type of conversion which is useful is to convert things to Booleans, which you can see people sometimes use. Now when it comes to number, the convention is that 0 is treated as false, and every other number, which is non-zero, is treated as true. So the Boolean value of 1 is true, the Boolean value of 51,512 is again true, but the Boolean value of 0, like we said, is false. And again, even if it's a very small number, it's still not 0, so it's true. Now, as far as strings are concerned, the rule is different. Here what happens is if you give it a non-empty string, then you get true. If you give it an empty string, you get false. So unlike Boolean of the number 0, which used to be false, if you give it a string of length 1, which has the letter 0 in it, so the string 0, this time if you convert it to Boolean, you get a true, not a false, because again, it's a string, and with a string, the rule is different. But if you give it an empty string, then you will get a false. And the rule for none is that it's always treated as false. So Boolean of none is just false. Another thing important in Python is to write comments. As you can see, we wrote many comments in the code, and it's a very good practice that I encourage you to use as well. It will allow you to better organize and maintain your code. So it's very important to add comments both for you and for other people reading your code. So in order to write comments, you can use the hash symbol. so like this. Okay, and you can write a one-line comment. When you go to the next line, it will be code. If you want another comment, you need to write hash again, and then you can continue your comment. Okay, another way to write multiple line comments is to use 3 quotation marks. It can be single quotes or double quotes. If you use 3 of them together, then this will begin a very long quote that can continue as far as you want, for as many lines as you want, until you give another 3 quotation marks, and then it ends. Okay, so you can see this is a 3 lines comment. Here you have just 1 line, but again, it could be as many as you wanted. Okay? And it's also very useful for commenting what is known as commenting out code. So suppose that you used to have this code, did something, but now you no longer want this code. You just want the thing that follows afterward. You can just put a comment in the beginning, and this is a nice way of, making this code not running while not deleting it. So if you suspect that you may want to return it later, or you are not sure yet, and you're not ready to delete your code yet, you can just comment it out, and it will not execute. It will be treated like a comment. And there is actually a shortcut for that. If you hit the control and the slash button, which is right on the left of the shift button on most keyboards, then this can automatically comment in and out your code. So every time that you write it, it will either add a comment or remove the comment. And you can also do it for multiple lines of code. So you can select 2 lines and comment them in and out. It's actually a nice feature of Jupyter. Very nice. Okay, let's speak a little bit about numbers now. So like we saw, we can define integers and we can define floats, like you see here. And like we saw, the type of an integer is an int, the type of float is a float. And if you do some expression that involves both integers and floats, then Python knows how to handle that. It can automatically convert it and give you a sensible result. So if you add an integer to a float, you will get a float result. Now this also works for division. So in many programming languages, if you use the divide operator, you will always get an integer which will be a rounding. So only the integer part of the result. But in Python, it actually will always give you a float. So if you divide, even if you divide 2 integers, the result will always be a float, which is the exact result. And again, this is again something that changed between versions of Python. So in Python 2, this used to actually give an integer. So the result used to be just 2 when you did that. Unless you did something to make it more Python 3 compatible, like using the font future import division kind of syntax. Now in Python 3, if you actually want to do the classic way of dividing, if you just want the integer part of the result, then you can use the twice divide operator. So instead of using 1 slash, you can use 2 slashes. And then the result will be just the integer part, okay? So it will get rid of everything after the decimal point and will just give you the integer part, which is 2. Now notice that even if you give it 2 integers that could be, divided without having any remaining part, and you can just have an integer result, it will still give you a floating point result, okay? So 4 divided by 2 is not an integer, 2 is a float 2. It's 2.0, like you see here. And of course, like we learned in school, you're not allowed to divide by 0. you can use the percentage operator to calculate the modulus, so to get the remaining part of a division. So for example, if you try to divide 5 by 3, you get a whole part of 1, and then you have a remaining part of 2. So the remaining part, the modulo of the division of 5 by 3, will give you 2. This is actually a very useful way to test whether one number divides by another number. So if you're not sure whether 723 divides by 3, you can just calculate the modulo, and if you get 0, then the answer is yes. So you can do a check like that, and only if it divides by 3, you will get a true, otherwise you get false. You can also use, so we saw that you can use asterisk once to calculate multiplication. If you use twice the asterisk, the star symbol on your keyboard, then this actually means power. Okay, so now what Python calculates, it calculates 5 to the power of 2,712, which is a rather large number. And again, this is another unique property of Python. In many programming languages, it will just give you a float, so it will give you some estimate. So you will get this scientific notation of, I don't know, e to the power of 1,000, say, more or less, as the result. But Python, if you give it two integers and you ask to calculate the power of them, it will actually make the exact kind of symbolic calculation, and it will give you an integer of very large numbers. So integers in Python, unlike in many other programming languages, they are not limited by size. It can be even larger. Okay, so again, if you give an even greater power, you will get an even longer integers. So you need to be careful of that, because if we give something that is too large, this can, just keep working indefinitely and make your Python environment stuck, and you will have to reset it. Okay, so that's power of integers. But if you calculate the power of two floats, then actually Python knows to give you a floating point result. And if it's too big, it will just give you a too large error. And again, you can give two floats to calculate the power of them, and you will get a rough estimate, because now it's float, so it's not an accurate result. It's a kind of approximation of the calculation. You can also calculate the power to a negative number and get its approximation. And you can even use the scientific notation yourself if you want to define numbers. So for example, if you want 4 times 10 to the power 5, you can write it like that. So this will basically create a float of 400,000, because you take 4 times 10 to the power 5, which is 100,000, and you can see the result here. And this also works with negative exponents. So if you want 0.004, so 4 times 10 to the minus 3, that's the way you can write it. And like you see, it gives the same result. So 1 E6 means 1 times 10 to the power of 6. This is indeed 10 to the power of 6. So this is 1 million. Now make sure you don't get it wrong, because this is a very common mistake that I see beginner programmers sometimes do. So if you want 10 to the 6, if you want a million, this will be 1e6, not 10e6. So if you give it 10 times 10 to the power of 6, this will already become actually 10 to the power of 7, so 10 million. Okay? So that's actually wrong. And you can even calculate the powers of fractions. And again, it has, even if the result is a complex number, then in Python 3, it will give you a complex number. Not very useful for biology, but just And again, like we learned in school, there is this notion of which operators come before which. So we know that multiplication precedes addition, So 2 times 3 plus 4 is, what it actually means is 3 plus 4, which is 10. But if we want 2 times 3 plus 4, then we need to add parentheses, okay? So if we want this to happen first, so we actually want 2 times 7, which is 14, we need to add those parentheses. And even if it's not important, like in this example, it doesn't hurt to put parentheses. So we can either put it or not put it. The multiplication will happen first nonetheless. So essentially the same results. Okay, now we can take strings and convert them to numbers. So if we just take a number like 5, we can convert it to an integer and get a number 5. Or we can take 7.7 and convert it to float and get 7.7 as a float. And you can see this actually works. It's 5, 7.7. And now if you add them, then you add them like numbers, because now x and y are actual numbers. They are integer and floats. And you can also take a string of integer and convert it directly to a float, like you see here. Now, unfortunately, you need to pay attention. This doesn't work the other way around. So if you try to convert 7.7 into an integer, you will actually get an error. It will say something which is actually quite cryptic and non-intuitive. I recommend you to remember this kind of error, because again, this is very non-intuitive, and this is a mistake that is very common when we program to try to convert a float string into an integer. It doesn't tell you that it got a float string, it gives you a more cryptic message. It says invalid literal for int with base 10. It basically complains that it doesn't know what to do with this dot symbol that you have here, because it tries to convert it to an integer. Okay, so what you need to do instead, if you want to convert the 7.7 string into an integer and you just want to get 7, what you can do instead is just to convert it to a float, to get 7.7 as a float, and then to take this float and to convert it into an integer, and you will actually get 7. Now, we saw that we could convert numbers into Booleans. It also works the other way around. And here the rule is very simple. True is just 1, false is 0. So you can either convert them to integer or to floats, and you get 1s and 0s like you expect. Now, what would I get if I tried to take the integer 5 and convert it to a Boolean, and then take that result and convert it to an integer? What would be the answer? So take a moment to think about that. Okay, so the result is 1. Why is it 1? Like we saw, converting 5 to a Boolean would just give you a true. And we saw that the Boolean value of true is always 1. So the integer conversion of the Boolean conversion of 5 is simply 1, like you see here. Another useful set of operators that you can use is the plus equal, minus equal, etc. So for every operation that gives you a result, there is a corresponding operator that, instead of returning a result, just applies it on an existing variable. So for example, if we have x equal 5, if we have x plus 5, it's 10. And we can get it and put it into another variable. But if we do x plus equal 5, then what it basically tells Python is that we want to take x plus 5 and then to assign it back to x. So this is actually equivalent to writing x equals x plus 5, okay? So these two lines of code are actually completely equivalent. Okay, so x plus equals 5 means take the value, the current value of x, add 5 to it, and then store it back into x. So after you execute this line, you can see now the value of x is 10. And now you can use the minus equals operator to actually reduce the value of x from using a different number. So basically taking x, reducing 3, and storing the value back to x. And like you expect, you get a 7. Or you can use the multiply equals by 5 to update its value now to 35, after it was 7 before. And now that it's 35, you can do divide equals with float result, or with integer result, or with the float result. And even power equals, everything works like you expect. Okay, so I think we'll stop here and take a break. And in the next part of the video, we're going to continue our discussion and speak about strings.